Alright guys, in this session we're going to take a look at 6.4, least common multiple. So yesterday we worked with greatest common factor, and now we're going to work with the least common multiple. Okay, here we go. Alright, the least common multiple, what is it to begin with? It is the smallest number that two or more given numbers can go into. And the most often time that we use this, and we use it actually quite a bit, more than you think, is finding a common denominator. You might do this process in your head a lot of the times when you're trying to find a common denominator, but if you couldn't think of a common multiple for those two denominators, you could make a list of them, and there you'd be finding the least common multiple. Okay? So most often used with least common denominator. Makes sense? Least common multiple, least common denominator, right? Alright, let's see what our steps are. To find the least common multiple, there are two steps, and they're very similar to yesterday's. There's only one small change, so you have to be thinking when you're doing these. First step is to make a factor tree for each number, just like you did yesterday. And your second step is to multiply the common primes. Yes, you did that yesterday too. Here's the difference. And multiply that with the primes that are not common. Okay, so let's talk about what that means for a second. Yesterday you did a factor tree and you just found the common primes and multiplied them. Today you're going to make the factor tree, find the common primes, get that answer, and then multiply it by all the leftovers. So all of the primes that were not common to both numbers. So that kind of looks like this. To find the LCM, you take the GCF times what's left over. So it's, rather than that longer definition up above, basically LCM is taking the GCF times what's left over. So in order to find least common multiple, we have to find the greatest common factor first. Okay, so what's in blue there, that is something that you definitely want to make sure that you understand. To find least common multiple, we're going to take the GCF and times it by what's left over. Alright, so make sure you pause the video until you have everything written down, and then we're going to show you two examples of how that works. Alright, if you're ready to move on, here we go. Here's our first example. I'm just going to do it with two whole numbers so you can see it in action. So bigger ones, 168 and 462. So start with your factor tree, and again, you can make your factor tree any way you want. This is how I made 168. Remember, you're circling your primes, because then the branches are done. And then make a list of the prime factorization of 168. So, and we don't use exponents here, remember. Then do your prime factor tree for 462, and again, you can just copy at this point because you could do it a different way. I'm sorry, I don't know why that says 154. Let me fix that there. That should be 462, what I was thinking. Wrong number up there. Let me fix that for you before we go on. So actually for 462, here's our prime factorization. Okay, so that we did yesterday. And then the GCF, to find the LCM, we're going to take the GCF times what's left over. So let's find the GCF first by circling the common pairs. So it looks like we have a 2, a 3, and a 7 that are common. So 2 times 3 times 7. And to find the LCM, we're going to take that GCF and multiply it by all the numbers that are left over. So on 168, we have a 2 and a 2. I know that's kind of covered up, but that is a 2 and a 2. And on 462, we have an 11. So the leftover is 2 times 2 times 11. Okay? So our two answers here are our GCF, which is 2 times 3 times 7, which is 42. And your least common multiple would be that GCF, 42, times the leftover, and the leftover is 2 times 2 times 11, or 44. And then when you multiply those two numbers, you get 1,848. Okay? Take a moment to let that all sink in. Make sure you understand what we did is basically yesterday's work, but we're taking yesterday's work then times the leftovers, and that gives us the least common multiple. Okay? When you're ready to move on, we're going to do an algebraic expression. Alright, here we go. Here's our algebraic expression. Okay, and these are two expressions. 51 n to the second p, and then 68 n p to the third. So we did our prime factor trees there. So do it for the number first, just like we did yesterday. And 51 is 3 times 7, and then times n times p. So 3 times 17 times n times p. And then for 68, we have 2 times 2 times 17 times n times p times p times p. So I just wrote out the prime factorization. Same as we did in the last example, same that we did yesterday. Now to find the GCF, we're going to circle all the common primes here. We have 17, and one set of n's and one set of p's. So the GCF is 17 NP, right? Then the LCM is going to be taking that answer times all the leftovers. So your LCM is the GCF times the leftovers, and here's what that looks like number-wise. So 17 NP times 2 times 2 times 3 times N times P times P. Okay? Makes sense where that's at? Now we're going to figure out that answer. So make sure you pause the video here to make sure that you have all of that copied down, and that not only that you have it copied down, but that you understand it as well. And then let's move on to the next section and see how that answer works. Here we go. All right, this is what we're finding for the LCM. We're going to multiply 17 NP times the leftovers, which is 17 NP times 12 NP to the second. So yes, we have to multiply those. How do you do that? It's a little easier than it looks. First of all, just multiply your numbers. 17 times 12, and that gives you an answer of 204. And then we're going to multiply our variables. So n times n, or n to the second power, right? And then p times p to the second. That actually is p to the third. When you multiply variables, you want to add the exponent. So p is like p to the first, and p to the second is p to the second. So 1 plus 2 is 3. That's how you get p to the third. N is n to the first. So 1 plus 1 is 2. That's how you get that there. Okay? Make sure you pause. Maybe you have to rewind and watch that again. But basically, you're multiplying the numbers, and then you're going to multiply your variables. And the variables, really all you're doing there is adding the exponents together. Okay? So that's our LCM. Pause, rewind, whatever you need to do to make sure you've gotten it. And then our last slide here is your mastery. So make sure when you're finished with this one that you raise your hand, show me your work, and then you can get your sheet. Very similar. All right, here we go. 27x cubed y squared and 48x squared y to the fifth. Remember to locate your prime factorization, find the GCF, and then take the GCF times the leftovers for the LCM. Okay? Good luck.